Hey guys, hope you're well. So here we have a grade 12 May-June exam for Maths Literacy paper 2, and it's 150 marks and 3 hours long. You can download the paper by checking the description below. Safiso is a builder who uses building plans and measuring instruments. Some measuring instruments and scales used by builders are shown below. Okay, so we need to choose an item that matches column A with column B. Now, in column B, you can see there's 1, 2, 3, 4, 5, 6, 7, whereas here there's only 5. Okay, so there won't necessarily be a match for everyone. So with this first one, number 1.1.1, it says, what is the most appropriate scale to draw a map of South Africa? Now, if you go look at most of the maps that you would have used when practicing in class, it's usually these 1 to 50,000s. Those are the most popular ones that we use in South Africa. So for question 1.1.1, we will say D. Now for 1.1.2, it says, what is the instrument that is most suited to measure the circumference of a dinner plate? Okay, so a dinner plate, you know, the plate that you eat your food on, it's not that big. So if you wanted to measure the circumference, you'd probably just use one of these, okay? If you tried to use one of these, it's going to be difficult because they don't really bend. And if you have a plate, you got to be able to bend it all the way around. Okay, so I would go with E. For this question, it says, what is the most appropriate scale to draw a plan of a house? Well, now, a house is not like super big where you would want to be using like 200 kilometers. A house is typically, you can use meters. So I would go with G, where 1 centimeter will be the same as 1 meter. That'll work perfectly for a house. For this next question, it says, what is the instrument most suited to measure the width of a soccer field? So for a soccer field, I wouldn't use this because these ones can only go up to, I think this one says 3 meters. Some of them go up to like 10 meters, but that's not enough. Whereas these ones are usually pretty big. They can go, I don't know exactly what they go, but they're more than 10 meters. Okay, so that would be the best one for a soccer field. And then what is the instrument most suited to measure the length of a pencil? Well, a pencil is straight, and so, or actually, I wouldn't use that one. I would say we could just use a ruler. That would be the best. Okay, the first thing I want to let you know is that this question does carry on. So we've got this question over here, and then we've got this one, and this one. Okay, so 4 parts that we will be looking at. So let's start. They tell us that the sketch below shows a standard brick with dimensions used in South Africa. Okay, so we've got this length over here is 240, we've got a width of 112, and we've got a height of 70. All of it is measured in millimeters. Oh, and then here they also say length, width, and height. Okay, then the first question says, state which formula, A, B, or C, can be used to calculate the total surface area. Okay, so total surface area, that is the area of all of the parts. So for example, this first part in the front, how would you find the area of that? Well, that would be, we know that a rectangle is length times, well, it depends how you want to look at it, but a rectangle is always this length multiplied by that length. So it's like the length multiplied by the height, okay? So for this red part over here, it would be 240 multiplied by the height, which would be 70, okay? So that is what surface area is. You would do it for this piece, and then you would also do it for the piece that's at the back. You would do it for all of the pieces, okay? So let's start with A and see if that one works. So it says that it's the area of the front side. Then there's the right-hand side, and then there's the top. Okay, so the top, then there's the right-hand side. I think that would be there, and then the front. That is not good enough, because what about the bottom? What about the left-hand side? What about the part that's at the back? So A is definitely not enough. The formula needs to give us all of the surface areas, not just some of them. Let's look at B and see if B works out. So they're saying that it's 240 multiplied by 70. So 240 multiplied by 70. Okay, so that gives you that part. And then what I like is they're multiplying it by 2. Why are they doing that? Well, that's because there's also the same at the back. You see? So that's where the multiply by 2 comes in. So I like that part. That takes care of this part and at the back. Now, this part over here is 240 times 112. So 240 multiplied by 112. Oh, okay, so that's the bottom. And then they're multiplying by 2, so that's the bottom and the top. Wow, very nice. This formula looks good. And then this part over here is 112 multiplied by 70. So 112 multiplied by 70. And then, of course, they multiply it by 2 because there's also a part that's at the back. So this formula is perfect. It takes everything into consideration. So that'll definitely be the answer, B. This question says, state the unit of measurement for volume. Okay, so volume, well, let's talk about that a little bit. If we're measuring perimeter, for example, perimeter is just measuring like the distance, for example. That would just be millimeters because we're using millimeters. If you use area, I'll give you a little tip. How do you calculate area? So for example, if this is 3 and this is 5, how would you calculate area? Well, you would say this multiplied by this. So how many things did you just multiply? Well, you multiplied 2 things together. So with area, we always use to the power of 2 because you're multiplying 2 things together each time. Now, what if you have a 3-dimensional shape? Like that, for example. Okay, then all of a sudden you're going to have a number there, and then a number there, and a number there. So if you wanted to calculate the volume, then you would actually end up multiplying these 3 numbers together. And so how many numbers did you just multiply? 3. So for volume, we multiply 3 things together, and so we use to the power of 3. So the units that we would use would be millimeters, because they want us to use millimeters, and then to the power of 3. Instead of saying millimeter 3, you could have also said cubic millimeter. You can also say cubic millimeter, because when it's a 3, it means cubic. This one says, convert the length of this brick to meters. So the length is this one. Okay, so now we got to be careful. We know that it's measured in millimeters, but they want it in meters. Now, what most of us might prefer to do is to first go from millimeters to centimeters, and then from centimeters to meters. I wouldn't go straight from millimeter to meter unless you really understand how that works. Okay, so let's go from millimeter to centimeter. So we need to know the conversion. If you look on your ruler quickly, if you have a ruler next to you, you know a centimeter, right? A centimeter is like that long over there. So that's 1 centimeter. Now, inside that centimeter, if you look on your ruler, there's these little lines, and those are called millimeters. There are 10 of those in 1 centimeter. So there's what we can remember. 1 centimeter is the same as 10 millimeters. So can you see which number's bigger? Look at that, 10 millimeters and 1 centimeter. So the millimeter number is larger. So here we have 240 millimeters, okay? 240 millimeters. So we need to divide that by 10 to get it to centimeters, which will then be 24. So you see how centimeters is always a smaller number. Okay. Now, we need to now remember the conversion between centimeters and meters. We should know this by heart, but we should remember that 1 meter is the same as 100 centimeters. Okay, so which number is bigger? Is 1 bigger or is 100 bigger? Well, of course 100 is bigger than a 1. So what I'm trying to say is that centimeter, the number will always be a larger number. So here we have centimeters. So if you want to change that to meters, you're going to have to divide that by 100. And that's going to give us 0.24 meters. This question says, determine the maximum number of rows of bricks that can be stacked height-wise to a height of 2,100 millimeters. So what they mean is, let's say we've got this, let's say we're going to put these bricks on top of each other. Okay, so there's 1 brick, 2 bricks, 3 bricks. Now remember, each brick has a height of 70 millimeters. 70 millimeters, this one's also 70 millimeters, and of course this one is also 70 millimeters. They want to know how many bricks can we put on top of each other if the height is allowed to go all the way up to 2,100. So all the way up to 2,100. Okay, so we can just say 2,100 divided by 70, and if you do that, you should get 30. So we could say 30 bricks. That means they could put 30 bricks on top of each other. So this question will carry on. So here we're going to do the first part, and then it does carry on to a second part, a third, a fourth, and a fifth part. Okay. So let's start. It says that Maria uses the recipe below to bake scones, or scones, whatever you want to call that. So we've been given some ingredients, and this makes 1 dozen. Remember, 1 dozen means 12. I'm not sure if we're going to need that, and here we can also see there's 12. 3, 6, 9, 12. Okay, so you need 75 grams of butter, eggs, sugar, baking powder, milk, flour, and raisins. So, and then you're going to bake it for 15 minutes at 200 degrees Celsius. So the first question says, convert the mass of flour. Where's the flour? There it is. Convert that to kilograms. Okay, we need to remember that 1,000 grams is the same as 1 kilogram. So what I always like to tell learners is, look at this. Which number's bigger? Look at that. There's 1,000. And then that's only a 1. So the number in front of the grams is always the bigger number. So if you have 500 grams and you need to change that to kilograms, is the number going to become bigger or smaller? Well, the number should become smaller because the number in front of the grams is always bigger than the number in front of the kilogram. So you are going to divide by 1,000, and that is going to give you 0.5. Don't forget the units. Kg. The next one says, determine the number of eggs needed to make 30 scones. Okay, because remember, this only makes 12. So how many eggs is that? So what we can say is that 2 eggs will make how many scones? 12. So what we can do is then say, okay, I mean, there's so many different ways you can do this, but what I would do is I'd say, okay, if I have 1 egg, then how did I go from there to there? Well, I divided by 2. So what you do to the one side, you do to the other side. So if you have 1 egg, then you can make 6 scones. Okay. Now, how could I get this to a 30? Well, 6 multiplied by 5. And in mathematics, what you do to the one side, you must do to the other side. So this means that 5 eggs would give us 30 scones, because 6 times 5 is 30, and so there's the answer, 5 eggs. This one says that each scone has an average diameter of 7 centimeters. So remember, if you have a circle, then the distance that goes right across, that is called diameter. And they told us that that is 7 centimeters. If you want to know the distance from the middle to the side, that's called the radius. And that's 3.5 or 3.5 centimeters, because it's always half of that number, and that is 3.5. Okay, let's just write that a bit better. 3.5 centimeters. So here it says, write down the average radius of each scone. Oh, well, that's 7 divided by 2, and that's going to be 3.5 centimeters. This question says, calculate how many full dozen scones can be made with 500 grams of butter. So we know that if you have 75 grams of butter, then you can make 1 dozen. Okay, so let's just write that down. 75 grams of butter will give us 1 dozen. Now they want to know, if you have 500 grams of butter, then how many dozens can you make? So what we can do is we can say 500 divided by 75, and if you had to go work that out, now that's going to give you 6.67 dozens. So how many full dozens would you be able to make? Would you be able to make 7 maybe? No, you definitely won't, because you're going to stop at 6.67. So how many can you actually make? Well, you would only be able to make 6 full dozens. So 6 full dozens. This question says that the scones were placed in the oven to bake at 10 past 2. Write down in words the time the scones were placed in the oven. Oh, okay, so that's just going to be 10 past 2. So we should say here that it's, so that's going to be 10 minutes past 2 in the afternoon. So this question will carry on. So here we've got the first part. And then there's a second question, a third question, a fourth question, and then a fifth question. Okay, so let's begin. It says, Busiswe participated in a VHI or VI, I don't know how to say that. I'm just going to say VHI, it sounds cool. Women's mini marathon, Annexure A, which is this one over here, shows the route of the mini marathon. Okay, so we can see there's a starting position here. They go this way, this way, this way, this way. Then they run there, and then they go all the way back. And it looks like it's a 10-kilometer race. Okay, so it says that write down the starting time using 24-hour format. What is 24-hour format? Well, it means that you can use numbers like 13, 14, 15, 16, 17, 18, 19, 20 to show the time in the afternoon. Okay, that's what 24-hour format uses. So it says write down the time. Oh, here it is. It's 2 p.m. So if that's 2 o'clock in the afternoon, then that's going to be 14 if you write it down using 24-hour time. Okay, that means 2 o'clock. This question says, determine the number of places where an ambulance can be found. So you got to look at a key. So there's nothing there, but then over here, if you look carefully, they tell us, there is an ambulance shown with those. So now we just got to go count how many we can see. So 1, 2, 3, 4, 5, 6, 7, 8. 8 ambulances. These people are not playing. 8 ambulances. This question says, state which mode of transport is not allowed on the mini marathon route. Here we can see the use of bicycles is not allowed, okay? But you can take a car if you want to and go do some donuts over there while everyone's running. No, I'm joking. But it says no bicycles, okay? So no bicycles. Okay, so this question says that the distance of a standard marathon is 42.2 kilometers. Okay, determine in simplified form what fraction of a standard marathon the VHI women's mini marathon is. Well, this one is 10 kilometers. You can see that it says 1 kilometer, 2 kilometer, 3 kilometer, it goes on and on and on. Here it says 9 kilometers, and then it says that there's 1 kilometer to the finish line. So that means it's a 10-kilometer race. Okay. So, to work out the fraction, you're going to say 10 out of 42.2. You're going to go type that on your calculator. And your calculator will always give you the simplified form. And so that's 50 out of 211. Okay, I know it's weird, but the calculator is doing a whole bunch of stuff to try to get rid of these decimals. Okay, so that is the answer, 50 over 211 or 211. Now the next one, which is part B, says give one reason why the VHI women's mini marathon is called a mini marathon. Well, it's because the distance that they are running is not the same as a normal marathon, so it's less. So they're calling it a mini marathon. So we can just say something here like the VHI race is shorter than a normal marathon. Okay, choose the answer and write only the letter A to C next to the question number. Okay, so it says that the probability of a runner crossing the railway line during this mini marathon. So where is the railway line? So now we can use this key over here, and so there's the railway line. So does a person ever cross the railway line? Well, no, unless they've gone completely off track. So are any of the runners going to cross the railway line? Definitely not. So the answer must be B, which is 0%. There's a 0% chance that would happen. So with this question, I know that you can't see everything very clearly now, but I will show you on the next page. It will look a lot better. But I just want us to see the introduction here. So Busiswe lives in Irene. Annexure B, which is going to be this one over here, shows the layout plan of Irene. Some streets end in a cul-de-sac. Now, a cul-de-sac is a street that ends in a dead end. You know, you've probably seen it before in your life where you go down a certain road and then there's like this big area here where you've got these houses, for example, But you have to turn around. You can't go. The road ends. Okay, that's a cul-de-sac. It's a street ending in a dead end. That is, it only has one entry and one exit. So you enter and you exit like that. Okay, I'm sure we've all seen that. So now let's go to the next page where we can see everything more clearly. So here's this map of Irene, and I just want to let you know there are going to be multiple questions that we're going to be doing. There's this one, this one, this one, this one, this one. Wow, there's a lot. And this one. Okay. So here we go. Write down the place of interest that is situated at the corner of Krieger Street and Bruce Street. So we need to go find those two roads. So Krieger Street and Bruce. Okay, so here's Krieger Street. I find it. And then Bruce Street is this one. So on the corner, we can see on the corner here, there's this house number 4. And so if we look at house number 4 over here, it's called a Scout house. So we could say Scout house. This question says, give the general, now check here, they're talking about direction, but look at this, east is over there, north is over there, so be careful, okay? Give the general direction from Bastion Guest House. Okay, where are you, Bastion Guest House? In an exam, I'd be freaking out if I can't find these things immediately. Where is Bastion? Woo! Palms are starting to get sweaty. That's if I was in an exam. So, where are you? Found it. There we go. Bastion Guest House. Okay, so it's this one over here. And it says to the station and shopping center. Now, is that one place? Oh, yes, it is. Thank goodness. Station and shopping center. Which one is that? Is that this one? Yeah, station and shopping center. Oh, it makes sense. There's a railway line, so that would be the station, and then that would be their shopping center. Okay, so it says give the general direction from Bastion. So it's going to go in this direction over here. So if you look here now, it's not going. It's going in between those two. So that's going to be southeast. Can you see that? Southeast. So we can say here south and east. Name the street that the railway line crosses. Okay, so here's the railway line, and it crosses this road over here. So what's this road's name? Oh, that's a weird name. Nelmapias. Nelmapias. Give the name of the church found in King Street. Okay, so here's King Street. Luckily, my eyes just saw that immediately. So there's King Street, okay? Now, apparently there is a church. I would imagine it's that one over there. Yes, that's a church because that says number 5. And if we look at number 5, it says St. Martin's Church. So that's the name of it. So we can say St. Martin's Church. All right, so here we've got quite a long question. So it says, Busiswe gives David the following traveling instructions to meet her. They're going on a date. So it says, drive from Irene Pre-Primary. Okay, so Irene, that's Irene Primary School. Is that the same as the pre-primary? Let's just be careful here. Here's Irene Pre-Primary. Okay. So this is a pre-primary school over here. So it says that we are going to drive from Irene Pre-Primary in an easterly direction along Crawford. Now, east means going up in this map. So there's Crawford. See, there's Crawford. Okay, so we're going to drive up there. And now we're going to turn left onto Queen Street. Yep, this is Queen Street. Makes sense. And then take the first right into Stanley. Turn right. Stanley Street over here. And continue up to King Street. Okay, sure. And then turn right into King Street, pass 5 streets, and then turn left. Okay, so let's turn right. Okay, so I don't think that counts as a street, so we won't count that one. 1, 2, 3, 4, 5. Pass that one, and then turn left. They said then turn left. Okay. Continue across the first street. Okay, so go across the first street. So go over this one because they said go across it. All right.
And then before the next intersection, an intersection is this area over here, Busiswa will be waiting for David. Okay, so Busiswa is going to be waiting for David over here. Ooh, they're meeting at the hall. Okay, so it says identify the place where Busiswa will be waiting for David, and that is going to be at the hall. But now I see that they did point over here, and there's a big bubble over here, so it's got a proper name, Irene Library and Hall. And I see on the memo that that's what they wanted. Irene Library and Hall. Maybe they're just doing like a study thing together. They're going to go study at the library because they have exams or something. Oh, that's what they told their parents. Okay, guys, I'm just being silly. Okay, so let's move on to the next question. This one says that the actual straight line distance as the crow flies from the entrance of Irene Pre-Primary, okay, so here's Irene Pre-Primary, to the entrance of Irene Primary School, which I saw earlier is over here. Okay, so they're saying that the actual straight line distance as the crow flies. So remember, if you have a car, obviously you're going to drive like this, like this, like this, like that, for example. Okay, or you could go this way, but I see there's arrows here, so it's a one-way road. But if you're a bird, then you would just go straight like that. Boom. That's called as the crow flies. Okay, so they said that the actual straight line distance as the crow flies is going to be 1.9 kilometers. 1.9 kilometers. Determine, rounded to the nearest 1,000, the scale of the layout plan in the form 1-2. Okay, so they want us to pretty much make some type of scale here. So you would have to take out your ruler, okay? And what you're going to do with that ruler is you're going to measure from the entrance of Irene, which I guess is over there, and then you're going to measure that to from the entrance to the entrance of our... Okay, we just got to make sure we're finding the entrances here. It's really difficult to know which one exactly is the entrance, but I guess if we just go there, and... Or maybe it's these... I don't actually know exactly which ones the entrances are. Okay, I'm just going to go in sort of that area over there, and then that area over there. Now, take your ruler, and then you would go measure that distance, okay? So how much did you get? Okay, so if you've done that correctly, you're supposed to be getting around 8 centimeters, okay? So what that then means is that 8 centimeters is the same as 1.9 kilometers in real life. So this is on the map, and then this is what it actually shows us in real life. Okay, so we need to try convert this now to some type of scale. So I think let's keep this one in centimeters, and then let's change this to centimeters. So we need to convert the kilometers to centimeters. Now, I think what most learners would prefer, I know I would prefer this, is to first go from kilometers to meters, and then from meters to centimeters, okay? So we should know that if you have 1 kilometer, then that is the same as 1,000 meters. So look at the number. So let's quickly change this to meters. That means that 8 centimeters is going to be the same as 1,900 meters, okay? Then we should also know that in 1 meter, there are 100 centimeters. So we're going to multiply this by 100 now. So that means that 8 centimeters is the same as 190000 centimeters. Okay. Now we need to get this this part here to a 1. So how do you do that? Well, you can divide this side by 8, and in maths, what you do on the one side, you have to do on the other side. So here we're going to end up with 1 centimeter is the same as... Oh, it divides perfectly. So 23750. We can drop the centimeters now, so it can be like that. But then they said they would like us to round it to the nearest 1,000. So if you round this to the nearest 1,000, that's going to be 24,000. So it'll be 1 to 24,000. Now, they did say on the memo that some learners, when they measure the 8 centimeters, some learners might measure 8.4, depending on how you do it. If you did use 8.4, then your answer would be 1 to 23,000. Okay? This question says, explain why a driver traveling along King Street, which is this one, cannot turn right into Bruce. Where's Bruce? Okay, well, here's Bruce Street, and we can see from the arrow that on Bruce Street, you're only allowed to go in that direction. So if a driver's coming along King Street and then they just decide, hey, I'm going to turn right over here, well, then they're going to be going into a one-way road. So we can say Bruce Street is a one-way road. Turning right will cause the driver to be going in the wrong direction. Like that. This question does carry on, so here's the first question. Then there's a second part and a third part. Okay, so it says here that Shecho is renovating her home. She is removing the wooden framed windows, okay, and is replacing them with aluminium framed windows. Ooh, fancy. So it says the dimensions and the shape of 2 of the window frames are given below. In the rectangular window frame, 4 windows can open. So 1, 2, 3, 4. And then it has 3 sections, A, B, and C. The circular window frame has no windows that can open. Okay, because that's always nice to have no windows that can open. Who needs fresh air? So, okay, and then they go give us a whole bunch of dimensions over here. So we've got some dimensions, and then here we've got a dimension as well. And then we've got formulas, okay, for circumference, perimeters, areas, all of that. The first question for 3 marks says, determine the perimeter of the rectangular window frame. So they've given us a perimeter of a rectangle formula. So we can say perimeter of the rectangle. And let's just go write that down for ourselves. So it's 2 and then in brackets, length plus width. So that's going to be 2, and then what is the length of this entire window frame? So it's the whole window frame, right? So it's all of this. Okay. So the length would be A plus B plus C. So that's the length. So that's going to be A, which they said is 55 centimeters, plus B, which is 99, plus C, which is 55. And if you had to go work that out, that's going to be 209 centimeters. So we can put that over here, 209. The width is this one here, which is 149. Go ahead, type that all in. Let's see what we get. Okay, and that's going to give us 716. You're just going to say centimeters. You're not going to say centimeters squared because it's not area. And you're not going to say centimeter cube because it's not volume. This next question says, calculate the inner area in centimeters squared of the circular window frame. Okay, so they want to know, calculate the area of the circular window frame. So they pretty much just want to know, what is this area over here? So it's the area of a circle, which is given to us over here. So let's just write that down. Area of a circle is going to be 3.142 times by the radius to the power of 2. Now, they said in centimeters, but this is in millimeters. So we need to first convert the millimeter to centimeter. So if you get confused with this one, quickly take out a ruler. Now, on your ruler, you can see there's those larger ones, which we call centimeters. Okay. Now, inside that, there are these little lines, which are called millimeters. And if you look carefully, there is 10 millimeters inside 1 centimeter. So what I then tell students to do is look at these numbers. Which number's bigger, centimeter or millimeter? Well, there's 10 millimeters for every 1 centimeter. So the millimeter number is always the biggest number. I'm not saying millimeters are bigger than centimeters. I'm just saying that the millimeter number will always be bigger than the centimeter number. So if we have 605 millimeters, then to get that to centimeters, you would divide by 10, and that's going to be 60,5 centimeters. And that is called the diameter, you see, because it's going all the way across. But what we need is the radius. So we know that the radius will be half of the diameter, so we can say 60,5 divided by 2, and that's going to be 30,25 centimeters. That is the radius. Now we can go use our formula. So we can say 3.142 multiplied by 30.25 to the power of 2. Ooh, it's quite a big number, 2875. Now we're going to round that to 2 decimal places, 0.13. Now we are measuring area, so that's why we must use to the power of 2. This one says that one of the window panes of the rectangular window frame broke. Write the probability as a decimal that it is not one of the window panes that can open. Okay, so with the window panes, I guess each of these is a window pane. So that's a window pane, 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 and that's a window pane. So there are 7 window panes. They said, what is the probability that it is not one of them that can open? So remember, which ones can open? This one, this one, this one, and this one. So how many cannot open? Well, that would be 1, 2, 3. So 3 out of 7. And they said write it as a decimal. So we're not going to say multiplied by 100. We're not going to try get a percentage. So if you say 3 over 7 on your calculator, okay, and that'll be 0.42857 14286. Now they didn't tell us to round off or anything like that, so we'll just leave it like that. So with this question, it is going to carry on. So here we've got the first part. Ooh, there's a nice 9-mark question coming up, and then an 8-mark question coming up. So this one's got quite a bit to it. So it says here that Shecho intends tiling the dining room and lounge floors, okay? So he's going to put new tiles in the dining room and the lounge floors. The dimensions of the lounge floor are 4 by 5, and the dining room is 3 by 4. Okay, so we've got these 2 areas in a house, okay? So let's say this is the lounge. It's not how you spell lounge, Kevin. Lounge. And we know that that is 4 meters by 5 meters. And then there's a dining room floor, which is then 3 meters by 4 meters. And this is the dining room. Okay, so then we've got some information. So Shecho intends to use tiles that are 35 by 35. So those are the little tiles that he's going to use, okay? They're 35 centimeter, so they're square by 35 centimeter. 1 box of 4 tiles is going to cost that amount of money. The cement for the tiles is going to cost that much. And she needs 4 bags of tile grout, which is the stuff that goes in between the tiles. Okay. And then the cost of labor, so she's going to get some people to help her. And then the total budget to do all of this is 15,000. So the first question says, show that the total floor area to be tiled, which is this and this, is 32 meters squared. You may use the following formula: area of a rectangle. So for the lounge, we can say that it's going to be 4 multiplied by 5. So we can say 4 multiplied by 5. Plus, then the dining room is going to be 3 multiplied by 4. And if you had to work that out, that's 20 plus 12, which is 32 meters squared. And that's exactly what they said here. So this question says, determine how many boxes of tiles. So this is for 9 marks, okay? So this one's going to be quite involved. Determine how many boxes of tiles Shecho will need if an extra 10% of the number of tiles must be added for cutting and breakages. Okay, so does that make sense? Let me explain that to you. So we've got these 2 rooms that need to be tiled, okay? Or let's just say that it's one big room, because we know that it's 32 meters squared. Okay, 32 meters squared. That was for the 2 rooms. Now we're going to buy some tiles. These are how big the tiles are. Now we need to know how many tiles we should order, but remember we need to order 10% more tiles than what we need in case we need to cut some of them and in case some of them break. Okay, now the important thing when we're dealing with this is that the area here is measured in meters, but these tiles are measured in centimeters. So let's change these to meters. You could also change these. You could also change these ones to meters. But you've got to be careful when you're changing meters squared. It gets a bit more complicated. So I'm just going to say let's change these 2 quickly. So if you have 35 centimeters by 35 centimeters, that is, so if you change this one to meters, that'll be, remember to divide by 100, because in 100 centimeters there is 1 meter. So that's going to become 0.35. So let's write this nicely here. So area of one tile is going to be 0.35 multiplied by 0.35. And if you had to work that out, now don't round off, so that's 0.35 1225, and that would be meters squared. So that is the area of one tile. Okay, now how many meters squared do we need to fill up? 32. So we can then say 32 divided by 0.1225. So we can see how many of these can fit into 32. And so that's going to be, okay, 261.22. And that's how many tiles we would need. Okay, but now now obviously we can't order half of a tile or whatever, but let's just quickly go add on the 10%. So they said we're going to add on 10%. So what is 10% of 261.22? Well, that's going to be 26.122. So that's how many extra tiles we are going to have to buy. So how many tiles do we need in total? So that'll be 261.22 plus 26.122. And so that's going to be 287.342. Now we're going to have to round that up. So let's just round that to 288 tiles. Okay, now remember that one box has 4 tiles. So how many boxes would we need? Well, to work out the boxes, you could then say 287.342 divided by 4. And that'll be 71.84 if you round to 2 decimal places. But now you can't say you want 0.84 of a box. So we're going to have to order 72 boxes. So remember that 72 boxes is what we said from the previous page. I'm not sure if we're going to need that here. So it says, show by means of calculations if Checho's budget will be enough. Okay, so we're going to buy 72 boxes of tiles. Now each box is 143 Rand. So we could just say for the tiles itself, that's going to be 72 multiplied by 143,84. Okay, and that's already above 10,000 Rand, so 10,356.48. That's how much she will spend on tiles. Now, we're not only buying tiles, you also need to buy some cement. So, tile cement is 99 Rand for a 20 kilogram bag. Now, that 20 kilogram bag is going to cover 3 meters squared. But how big was our flooring? Remember, our flooring was 32 meters squared. Okay, 32 meters squared. So how many bags of cement do we need? Well, you could say that we need to cover 32, but each bag covers 3. So you could say 32 divided by 3, and that'll be 10.67 bags. But you cannot go to the shop and say, hello, can I please have 10.67 bags? That's not going to work. So you need to actually buy 11 bags. Now, how much does that cost? Well, each bag is going to cost 99 Rand and 90 cents. So we could say 11 multiplied by 99.90. And so that's going to be 1098.90. That's how much Rand the cement will cost. Okay. Now we also need to buy tile grout. So that's the stuff that goes in between the tiles. And she needs 4 bags. So they tell us that she needs 4 bags, and each bag is 89 Rand 90, because it says 89 Rand 90 per 5 kilogram bag. So she's going to buy 4 of those. So let's just say grout 4 multiplied by 89 Rand 90. So if you say 4 multiplied by 89 Rand 90, so she'll spend 359 Rand and 60 cents on tile grout. And then she also has to pay some people to help her install it, and that is the labor. Whew, I don't know if this lady's going to have enough. So the labor is going to be 2,500 Rand. So what is her total cost going to be? Well, that's going to be the tiles. It's the cement. It's the grout. I don't know why I'm so excited to see this. And then it's the labor. If you go ahead and work all that out, she has a good budget. That's going to cost 14,314. Let me write this a little bit better for us. Okay, I'm going to write the answer here, okay? 14,314 Rand and 98 cents. Now, what was her budget? Her budget was 15,000 Rand. So her budget is enough. Let's just say that here. Her budget is enough. With this question, we're going to be doing multiple parts. So here we've got our first question down at the bottom. Then we've got a second part and a third part. So Annexure C, which is this one over here, shows the seating plan for a cinema during the COVID-19 pandemic. Seats marked with an X need to be left vacant to comply with social distancing. Okay, so many of these exam papers are all about COVID. It's like 3 years later, guys. Come on. So obviously we've got some type of cinema. Here's the screen, and obviously you're not allowed to sit next to people, okay? So, here, 17 and 16, they're probably dating, and then they're not allowed to, and then you can't have anyone there, and then they're allowed to sit next to each other, and then you can't have. So all the X's are empty seats because of COVID. And so the first question says, on which side of the cinema is seat E4 from seat E15 when a person is facing the screen? Okay, when I read that, I'm just like, what? On which side of the cinema is seat E4? Okay, so let's go to E4. From seat E15, here's E15, when a person is facing the screen. Okay, so both of the people are facing the screen. Okay, on which side of the cinema is seat E4 from E15? So we're standing at E15, then which side of the cinema is E4? It's on the right-hand side. So we can say on the right. This question says, assume that pre-COVID conditions apply and all the seats are occupied. Okay, so all of the seats that are allowed to be occupied are occupied. This question says, name the row and the seat number of the middle seat in the 8th row from the screen. Okay, so the 8th row from the screen. So this is the first row, second row, third row, fourth row, fifth row, sixth row, seventh row, and 8th row. Okay, so this is the 8th row. Okay, now we need the middle. So I'm going to cross off from either side. And eventually we should arrive at the middle. There it is. Okay, so what we can then do is we can say that that is, it's row K, so we can say it's row K, and then this is 11, 11, 11, 11, 11, 11, 11, 11. So it's going to be K11. This next question says, write down the ratio of the number of wheelchair spaces, okay, so that's there, to the number of seats that are not wheelchairs or not for wheelchairs. Okay, so I was a little confused with this one, whether we need to include the parts where there's no seats available. And then I had to check the memo, and they want us to include everything, okay? So that one was a little bit confusing because no one's allowed to sit here, so I don't know why we're counting those as chairs. But anyways, so we need to count all of the seats. So there are 4 wheelchairs, 4 wheelchair seats, okay? Now we need to go count all the rest. So here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over there. Now, can you see that these blocks are all the same? So let's just go count one of them, and then we just multiply. So this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so that's 10 and then 16 multiplied. Now, how many are like that? 1, 2, 3, 4, 5. Okay, and then we can just go count here. 1, 2, 3, 4, 5. Oh no, this one's easy. Check if you're counting from 1 all the way up to 21, that's going to be 21 seats. And then for this next one, it's going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. This one's got 19 seats. Okay, so we can just say 10 plus 16 times 5 plus 19 plus 21. And that's 130 seats. So there's 4 wheelchairs and then 130 normal seats. Now, to simplify this ratio, what number can go into both of these? Well, the number 2 can definitely go into both of these. It can go into this one twice, and it can go into this one 65 times. And so that would be the answer. You can't simplify that any further, so it's 2 to 65. This question says that on Friday evenings, pre-COVID-19, all the seats in the cinema were always occupied. Oh, I see now with the previous question that we looked at over here, it said pre-COVID. That means before COVID. That means that all of the seats were available, and that's why they even counted the ones that have X's on them. Ah, I see, I didn't read that properly. Okay. So it says here, on Friday evenings, pre-COVID. Okay, so that means before COVID. Okay, so all seats in the cinema were always occupied, okay, except the wheelchair spaces, all right? Calculate the percentage income lost due to social distancing during the pandemic if all of the tickets for the seats are equally priced. Okay, so we're going to ignore the wheelchairs because they said here that excluding the wheelchair spaces. So look at all of those seats. Okay, so pre-COVID, how many seats were there? Well, we said there was 130, okay? Now, during COVID, how many seats are there? Well, now you can't have these ones. So let's go count how many X's there are. 1, 2, 3, 4, 5, 6. Let's just see here. Are all of these equal? 2, 4, 6, 8, 2, 4, 6, 8. Yeah, okay, so each of these rows, there are 8 X's. I mean, each of those rows, there are 8 X's, exactly. So there's 5 rows over there. So that's going to be 8 X's multiplied by 5 rows, which is 40. Here there are 4 X's. How many X's are there in J? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 over there. And then how many X's here? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if you go count up all of the X's, there's going to be 4 plus 40 plus 14 plus 8. And so that's 66. Okay. So, out of a total of 130 seats, how many seats are they not allowed to sell? Well, they're not allowed to sell 66 seats because those are the X's. So, they want to know what is this as a percentage. So, if you multiply that by 100, and then if we round that to 2 decimal places, that's going to be 50.77%. So that's how many seats are not allowed to be used. So 50.77% of the entire cinema is not allowed to be used. So that is also how much money they're going to lose. They're going to lose 50.77% of all of the money that they would normally make. Okay, so there's the answer. So with this question over here, it does carry on. So here we've got this first part, a second part, and a third part. Okay, so it says that a cinema owner uses a generator to continue showing movies during load shedding. Have you guys ever experienced that? I've actually experienced that. The other night I went and watched a movie at the cinema, and it was during a load shedding. So during the movie, the cinema actually went off, and it took about 10 minutes for the generators to kick in. So we just all sat there awkwardly like, hey bro, like we're just gonna chill and wait here. And then about 10 minutes later, the movie came on again. So yeah, it's quite interesting. So here they're using a generator to continue. Oh, by the way, there was actually at the same cinema where I stay, on one of the nights, one of the generators actually blew up. You see, the problem is that these companies, they're buying all of these generators, but they're not servicing the generators properly, and they're not taking care of them, and they're just letting these generators run so many hours without making sure that the generators are actually being well taken care of. And so it's happening in quite a few places where the generators, I've heard of it twice now in the area where I live, where the one was in a Pick and Pay and the other one was at a cinema, Stackinical, where the generator actually caught on fire. So it's quite dangerous. You've got to be careful. They must take care of them. They must make sure that these generators are being taken care of the way they're supposed to be. Okay? They can't just run 24/7, you know? They need to make sure, everything's being well looked after. Okay, so the cinema owner uses a generator to show movies during load shedding. The diesel is stored, so the diesel that they use for the generator is stored in a cylindrical diesel tank as shown below. Okay, so this is not the generator, this is the diesel tank that holds all of the diesel for the generator. Okay, so state the purpose of the breathing valve. Now, when I read that question, I'm like, goodness me, are we like studying engineering here? Or how are we all just supposed to know what a breathing valve is? Like, I don't know what a breathing valve's for. Okay, well, now, so when you think about breathing, it's usually for air or oxygen, right? So the breathing valve is to let air in and out, okay? So on the memo, some people, you're allowed to say that it's to let air out, and you're also allowed to say that it's to let air in. Okay, so I'm just going to say to allow, but I think that that's a really unfair question. Like, come on, that's not what we're learning here. To allow air in, but I mean, every exam's going to have those types of questions where 95% of the learners are probably not going to get it correct. They'll always have some of those in the test. To allow air in and out. Okay, next question says that the steel used to make the tank is 5 millimeters thick. For safety reasons, the tank is filled to 95% of its capacity. Instead of filling it all the way to the top, they're only filling it up to 95%. The first question says, show that the inner diameter of the tank is 3.21 meters. Okay, so you see how they're telling us from the outside to the outside is 3.22 meters, right? But now that tank has a thickness. Now, I'm going to make it look a little bit more thick than it actually is, just so I can explain. But that tank has a certain thickness, okay? Now, that thickness, they've told us, is 5 millimeters. You see how they told us here? So we're going to say 5 millimeters. Now, if we convert 5 millimeters to meters, then we need to do our conversions. So in 10 millimeters, that is 1 centimeter, okay? So let's quickly go do that. So 5 millimeters would become 0.5 centimeters, okay, if you divide by 10. Now, in 1 meter, there's 100 centimeters, okay? So you see how the centimeter number is bigger. So to go from centimeters to meters, you're going to have to divide by 100. So we're going to say 0.5 divide by 100, and that's going to be 0.005 millimeters. 0.005 meters. So this distance is 0.005 meters, but then this distance is also 0.05 meters. So they want to know what is the inner diameter. So you could say 3.22 take away 0.005 and then take away another 0.005. You see, if I show you from the front, if the inner tank is like that, then this distance here is 0.005 and this distance is 0.005, and so they want you to measure this distance over here, and we know that the outer distance is 3.22. Okay, so you have to minus it there and you have to minus it there, and so if you had to work that out, you're going to get 3.21 meters. The next question for 8 marks, calculate the maximum liters of diesel that this tank can hold. Okay, so we need to work out the volume of the inside of the tank. Please be careful, listen to me carefully. They said, yeah, all dimensions shown are outer measurements. So for example, this 3.22 is not the distance we are going to use for our tank, because remember that the tank, if you look at it from the front, it has some type of wall, okay, like the steel wall needs to have a certain amount of thickness. And so they've given us that distance as 3.22, but that's not the distance where the liquid is going to go. The liquid only goes over here. And so we already worked out that distance is 3.21 meters in one of our previous questions. So that's the first thing I need you to keep in mind. The second thing is that this distance here is from the outside of the tank to the outside of the tank. But once again, if I had to show you this tank standing upright from the side, or even if I just draw it like this on the side, this part over here, the wall, also has a certain thickness, okay? And that thickness is going to be 5 millimeters, because they said the steel used to make the tank is 5 millimeters thick, and it's also going to be 5 millimeters over here. So we can't use 7.25, we're going to have to use this distance, which we haven't worked out yet, okay? So I hope that makes sense. You can't use these numbers because those are for the outside, but the liquid, the diesel, doesn't go all the way to the outside, okay? So let's quickly go work out what this distance would become. We already worked out earlier that to convert that 5 millimeters into meters, it was 0.005 0.005 meters. Okay, so, and then you're also going to have it on this side, 0.005 meters. So to work out what this length actually is, where the diesel goes, we could say 7.25 take away 0.005, take away 0.005, and that would be 7.24 meters. Okay, so we're going to use 7.24 and we're going to use 3.21. Please keep that in mind. Now, we've got this tank, right? Now, to be able to work out how many liters of diesel we can put into that tank, we need to know the volume of that cylinder. So we can use this formula, but a lot of learners, they're going to look at this formula and they're going to say, we don't have the height. They're going to think, is this the height? But what does the height actually mean? Well, they're talking about a cylinder that's standing upright. Then this would be the height. Okay, that's the height. So if it's lying on the side, then what would the height be? Well, then it's this number. But Kevin, that's not a height, that's a length. Yes, but that's where you got to understand what the formula actually means, guys. They're saying that it's height, but they're talking about a cylinder that's standing upright. But so we're just going to use this number because they're actually just talking about what is the distance from here to here. That is what they talk about when they say the height, okay? But you could actually call it the length in this question. Okay, hope that makes sense as well. So we're going to go use that formula now, which says that it's 3.142 multiplied by the radius. Now the radius is always the circular part, whether it's standing up or whether it's lying on its side. So the radius, this distance over here we said was 3.21, but that is the diameter, right? If I show you what it looks like, we've got this little inner thickness over here. So the part where the diesel goes is here, and that's 3.21. But we need the radius, which is half of that. So we're going to half 3.21. So 3.21 divided by 2 is 1.605. Okay, so we're going to use 1.605 and we're going to square that because they said squared. And then we're going to look at the height, which is the 7.24, not 7.25, because that's not where the diesel goes, because of the thickness of those walls. The walls have to have a certain thickness, otherwise the tank would just collapse. Okay, and that's going to give us 58,5996278. Now, that's in meters cubed. Now, they said here that 1 meter cubed can hold 1,000 liters. Okay, so we can multiply that by 1,000. And so that's going to be 58,599.62278 liters. But now that is if your tank is completely full, but we are not going to make it completely full. We're going to only make it 95% full. So we're going to now work out what is 95% of that amount. Now remember, with percentage, you could say 95 over 100. Of means times. Okay, and if we go work this out, we end up with 55,669.64. And that would be measured in liters. So that is how many liters this tank can hold. Here's another 8-mark question. So it says that the external surface area of the tank, excluding the base area, of the external attachments, these are just like these parts over here, I think, those little weird parts, needs to be painted. So the external surface area of the tank, excluding the base area of the external attachments, needs to be painted. The spread rate of the paint is 3 meters squared per liter. The manager states that he would need less than 30 liters of paint to complete the task. Verify by showing all calculations whether the manager is correct. So the surface area of the cylinder can be calculated using this formula over here. Now remember, when they say height, they're actually talking about this distance over here. Now you've got to be careful. Are we painting the inside of the tank or the outside of the tank? Well, of course we're painting the outside. So now we can use this number because that goes from the outside to the outside, and we can use that number because that goes from the outside to the outside. You see, that's where it's important that you understand that. So we can just go work out this, use this formula. So the surface area is then going to be 2 multiplied by 3.142 Then in brackets here, oh no, then there's a times, then there's the radius. Now, that would be this. You can use this, but you must divide it by 2 because that's diameter. So we're just going to divide that by 2. I'm actually just going to say here 3.22 divided by 2. And then in brackets, there's 3.22 divided by 2 again, because there's the radius again, plus the height. But in this case, they're actually talking about this length, which is then 7.25. I'm running out of space. And if you had to go work that out, okay, now that would give us 89.6387.464. Now that would be measured in meters squared because it's a type of area. But now we've got to be careful. What that just calculated was to paint everything here on the outside, and to paint the entire tank on the outside. But you see how on the outside of the tank there are certain parts that we don't have to paint. For example, the breathing valve, the inlet, the ladder, the outlet, the stands. Okay? We don't have to paint all of that. So you see how we would have normally painted there, and we would have painted there, and we would have painted there. But now, because those things are there, we can save a little bit of paint because we don't have to go paint any of that. And we would have had to paint over there, but now we don't have to. And we would have had to paint over there, but now we don't have to because of that. So we're going to use less paint. So they told us here that the area of all of the external attachments is 1 meter squared. So we can minus 1 meter, and that means it's now 88,6387464 meters squared. That is the total area that we are actually going to have to paint now. Okay, now they've told us that if we need 3 meters squared, that'll be the equivalent of having to need 1 liter of petrol. 1 liter of paint. I don't know where I said petrol from. 1 liter of paint. Okay, but we have 88 meters squared of paint. So what we need to do is get this to a 1. How do we get this to a 1? Well done if you said we can divide it by 3, but then what you do to the one side, you must do to the other side. So then 1 meter squared is going to be 1/3 of a liter. Now how many, okay, so for 1 meter squared to paint, you need that many liters of paint, but how many meters squared do we have? We have that many meters squared. So we could now say 88.6387464 multiplied by 1/3, and so that's going to give us 29.55 if we round off liters of paint. That is how much paint we would need. The manager says we need at least 30 liters. So we can then say that the manager is correct. With this question, we're going to be doing multiple parts. So here we've got our first part, second part, and third part. So it says here that Letitia buys a new Bucky with a portion of her retirement funds. Okay, the dimensions of her Bucky and her the word Bucky is so funny because I've traveled to some other countries. I was recently in Thailand, and you got to be like not careful, but sometimes you'll see like a car like this, and then if you tell people, hey, look at that Bucky, they're going to look at you like something's wrong with you. Like this is such a South African thing, whereas all the other people I met from all the different parts of the world, like they use totally different words. So it's quite funny, the word Bucky. Like we use it so normally, but other people in other countries have no idea what that is. So, okay, so the first question, well, let's just first see here. They've given us the dimensions of this Bucky in millimeters. Okay, and okay, so this is the Bucky, and this is a garage. This is the garage where the Bucky walking. Okay, I get it. So they tell us here, identify which view of the Bucky is represented by the dimensions 1815 by 1860. So what you do is just go say there, 185 and then 1860. Okay. So if you're looking at the width and you're looking at the height, well, which parts of the Bucky would you be looking at? You're definitely not looking at the side. So you could either be looking at the front, because that would be 1860 by 1815, or you're looking at the back, 1815 and 1860. You could also be looking at the back. Okay, so you could say here, front or the back. Some of you might use, instead of using the word back, you might say the rear, like the rear view. That's also okay, R-E-A-R, rear view. Okay, this one says, calculate the value of D, which is the space between the side of the Bucky and the side walls. Okay, so what we can do is we can realize that we know this distance, right? They told us that that distance is 1,860 millimeters. So, of course, we need to convert that to meters quickly. So let's go do that. 1860 millimeters. Okay. Now, we know that we can convert it to centimeters first. So in 10 millimeters, that's 1 centimeter. Okay, so you see how the millimeter number is always bigger. So to go from millimeters to centimeters, we'll divide by 10. So we will divide that by 10, and that's going to be 186 centimeters. Now we know there's 100 centimeters in 1 meter. So you see how the centimeter number is always bigger? So to go from centimeters to meter, you're going to divide by 100. Okay, and that'll be 1.86 meters. So this distance across here is 1.86 meters. The total distance is 3.6 meters. So if we subtract those two numbers, so if we say 3.6 minus 1.86, we end up with 1.74 meters. So that distance, that would be this part and this part. So we can then say 1.74 divided by 2 to see what each of these halves would be. So we could say 1.74 divided by 2, and that would be 0.87 meters. So do you understand that? 0.87 meters there, 0.87 meters there. So together those two parts would give us 1.74. And then if you say 1.74 plus 1.86, that gives you a total distance across of 3.6 meters. If you did this question in millimeters instead, you should have ended up with 870 millimeters. This question says that Letitia needs to choose a color and a window tint. The Bucky comes in 4 different colors: white, black, blue, and green. The windows can be tinted using either 35% or 50%. Show how many different choices there are for this Bucky. Well, what they mean is the following. You could choose a white Bucky with 35% tint. Okay. You could also choose a white Bucky with 50% tint. You could choose a black Bucky with 35%, or you could choose a black Bucky with 50%. You could choose a blue with 35%, or a blue with 50%. You could choose a green with 35%, or you could choose a green with 50%. So how many options do we have? 1, 2, 3, 4, 5, 6, 7, and 8. So we could say 8. This question says that Letitia studies a strip chart connecting Springbok in South Africa with Windhoek in Namibia. On Annexure D is a strip chart. Okay, so let's have a look. Okay, so this is called a strip chart, and it's between Springbok, which is in South Africa, to Windhoek, which is in Namibia. So it says the first question, and there will be more questions, by the way. There will be a second question, a third question, a fourth. So question 4 has a part A and a part B. Okay, so it says state one difference between a strip chart and a normal road map. So in a normal map, right, all the roads are like curved and it shows you all of the curves, for example. On a strip chart, everything is shown as a straight line. Can you see that? So we can say here that on a strip chart, roads are shown as straight lines. On a normal map, roads are shown in a winding manner. Okay, so it just shows that they are more windy. Another option you could have said, so this is the one option. A second option you could have said is that a normal map is drawn to scale. A strip chart is not drawn to scale. Okay, that's the difference there. The next question, determine the distance between Springbok and Gobabas. Okay, so here's Springbok and Gobabas is over here. Okay, so you see from Springbok, if you go all the way up to here, look at the distance. Well, here it says 0 kilometers. Here it says 892. So that distance there is 892. So we can say that's not the final answer, 892. And then you also have to drive this piece from Windhoek to Gobabis, which is 203 kilometers. You see how it says here, 203. So we're going to say 203. And so if you add those together, it'll be 1,095 kilometers. This question says, identify the Namibian town found on the border between South Africa and Namibia. So the border is over here. Here's South Africa, okay? And then here's Namibia. So this line is the border. So you see there's 2 towns over here on either side of that border, okay? Now they said identify the Namibian town. So the Namibian side would be this one here, Noorduver, something like that. I don't know. Oh, and here also says border crossing. Okay, I was looking for that. So the answer is going to be Noorduver. All right, so here we have a 3-mark question. It says that Letitia undertook the following trip. She left Solitaire. Where is Solitaire? Solitaire, where are you? She left Solitaire at 4 o'clock and traveled 140 kilometers south on the C14. So this is the C14. This is also the C14, okay? You see how it says there, C14. It then says that she turns right and travels east on the C19. Okay, so remember, east is this way. Okay, so she's going to travel down there, and she's going to travel east then on the C19. Okay, and she traveled 289 kilometers. So 289 kilometers. At Marienthal, which is over here, she turned and then drove to Keetmanshoop, which is down here. Okay, so she went like this, like this, like this. And she arrived there at 12:25. Calculate the total distance that Letitia traveled during this trip. Okay, so she starts at Solitaire and goes down to here. So that's 80 plus 60. Okay, so that's 80 plus 60. Then she said she drove 289 kilometers, which is the 180 over here plus 109 over there. That also gives you 289. And then she drove on this road over here. Now, to work out that one's distance, you can look at this, which is 644, and this one is 427. So what is the distance between those? You could say 644, take away 427, and that gives you 217. So that's 217. And so that's going to be 646 kilometers. Okay, and then this part of here says that Letitia traveled on different types of roads and she maintained the average speed limit prescribed for each of these roads. She stopped 3 times during the trip to take a break. Letitia stated that the 3 breaks were approximately 25 minutes each. Verify with calculations whether Letitia's statement is correct for 11 marks. Wow. Okay. So, let's just remember where Letitia drove. She started at Solitaire, and she drove there, and then she drove there. We said that the total distance was 646 kilometers. Okay, but now we're going to look at the time for each part. So let's just ignore the time let's just ignore the stops for now, okay? Ignore the stops. So we know that this road here, all of this actually. So you see from here, this road here was a C road. And what is a C road? A C road is a gravel road, and you're allowed to go 80 kilometers per hour. Then when she turned over here and went to Marienthal, that's also a C road. How do I know that? It says C19. So those are gravel roads up to there. So on the gravel road, you are allowed to go 80 kilometers per hour, and we know that she wasn't speeding because it says here she maintained the average speed limit prescribed for the type of road. So for that area there, from Solitaire to Marienthal, she drove 80 kilometers per hour. That was her speed. Okay. Now, how far was that? Well, that was from Solitaire to there. That's 80 kilometers plus 60 kilometers plus 289. Remember, we said it was 289. So we can say that was 140 plus 289, and that would be 429 kilometers. So for that part of the journey, we have the speed and we have the distance, so we can calculate the time. So the time would then be 429 divided by 80, and that would be, don't round off, it's not the final answer, 5.3625 hours. Okay, 5.3625 hours. Now, and of course, she probably stopped along the way, but we'll just add that in later. Okay, now, when she gets to Marienthal, she's going to drive all the way to Keetmanshoop, and that is on a B road. You see how it's a B road? Now, where's a B road? There it is, and you're allowed to drive 120 kilometers. So she's going to drive a little bit faster now. Okay, so how far is that? Well, we worked out earlier that distance was 217 kilometers. Remember, we said this one minus this one. So to go from Marienthal to Keetmanshoop, we said it's 217 kilometers. We also know that her speed for that part is 120 kilometers per hour. So we can use these two pieces of information to work out the time for that part of the journey. So the time will just be equal to the distance, which was 217, and the speed was 120. So how long did that take her? 217 divided by 120. Okay, don't round off. I'm actually just going to leave it as a fraction. 217 over 217 over 120, and that would be measured in hours. Okay, so we can now get the total driving time, which would be 5.3625 hours plus 217 over 120. And if you had to work that out, I'm going to round that to 2 decimal places. That would be 7.17 hours. Okay? Then we just need to remember that she also stopped for 25 minutes every single time. Okay? And she stopped 3 times. Okay? So her stoppage time is going to be 25 multiplied by 3, which is 75 minutes. We need to convert that into hours. So you would say 75 divided by 60, which is 1.25 hours. If you said that her stoppage time is 1.15, then you're making a mistake. You're then saying that it's 1 hour and then 15 minutes for the 75-minute part. But you didn't just think about that part carefully, okay? So now what we can do is we can work out her total time. She traveled for 7.17 and then she stopped a total of 1.25. So we can say 7.17 plus 1.25. And so she drove for a total of 8.42 hours. That does not mean 8 hours and 42 minutes. You got to be careful with these, okay? So, what do they want us to do? Letitia traveled, she arrived at 12:25. We need to see if that is correct. So, you see this 0.42, you need to convert that to minutes. The way that you convert that to minutes is you just multiply that by 60. And so that's 25.2 minutes. So, she then traveled for 8 hours. So the total time is 8 hours and 25 minutes. So if she left at 4 o'clock in the morning, then she would arrive, if you add 8 hours and 25 minutes to that, you would arrive at exactly 12:25. So this lady, she is correct. She is correct.